pieces that you need. But we have not really done, except we've really only done like one of these where it was a definite integral so far. So we need to know what to do with definite integrals. And there's going to be sort of a shortcut that we are going to use that is going to make this a little bit quicker to do. With definite integrals, you can change the variable. So if you see here, we have the integral from a to b of f of g of x times g prime of x dx. So in this case here, why is my pen? Okay, there we go. In this case right here, your g of x would be your u, and your g prime of x dx, that would be your du. So what you can do for these problems is you can take your limits, so like this would be a number right here, it might be 1, might be 0, might be 10, whatever. You can take that limit and plug it into your u and change your limits. And we'll see that it's a little easier to see whenever it's in action. So the b right here would become g of b. And if you do this, everything is in terms of u, and you don't have to go back to x's in that case. I think it's easiest just to see an example of what this looks like. So for the most part, it's the same thing that we have been doing. You're going to find your u, you're going to find your du. If you're missing anything, you put that value in. So in this case, we would have the x squared plus 1 would be our u. And so du would be 2x dx. And so we've got the x and the dx that we need right here for our du. We are just missing the 2 right here, but if I put a 2 right there with that x, what have I got to do on the outside? I've got to put a 1/2 right there. So this stuff right here is my u. This stuff right here is my du. So whenever I rewrite this with my u's, I would have an 1/2 integral of u to the 3rd power du. Now, you have a couple options here, but one of them is going to be easier than the other. So right now, whenever I have my original function, it is a dx problem, which is telling me, although it's not written, it is telling me that x equals 0 and x equals 1. So if I put limits over here on this integral, because it's got a du, it would be implying that u equals some number and u equals some number here. So if you do not change your limits, you must put x equals 0 and x equals 1. Okay, and I'll show you in a minute what that would look like if you did it that way. But the best thing that you should do is going to make it a little bit quicker, plus sometimes they don't solve these problems all the way out. They just give you like an intermediate step as the answer, and they're going to change the variables if they do that. So what we're going to do here is we're going to take our lower limit, which is 0, where x equals 0, we're going to plug it in. And u would equal 0 squared plus 1. And that would be 1, so that would be our lower limit. So we have changed our limit so that it is a u.
Nervous for it, Justin? A little bit. I'm not really worried about it. It'll be fun.
All right. Then this top limit right here, we're going to do that same thing. We're going to plug it in for the u. So we'll have 1 squared plus 1, which will give us 2 that goes here. So just because I've got stuff going everywhere, I'm going to rewrite this. We got 1/2 integral from 1 to 2 u cubed du. I'm just rewriting that because it was a little messy right there for this. So now, because everything is in terms of u, I can just integrate this, and I don't ever have to plug the x back in. So I would have 1/2, and then I would have u to the 4th, and then I divide out front by that 4. And I don't put a plus c because this is a definite integral. Instead, I'm going to evaluate this from 1 to 2. And I'm going to go ahead and put the 1/2 and the 1/4 together to make it 1/8, because those will be multiplied together. And I would have 2 to the 4th power minus 1 to the 4th power here. So I got 1/8 of 16 minus 1, and that is going to give me 15 over 8. There is my answer.
The definite integral just means it has like that range.
Yeah, it means it has those limits there.
So like the plus c, it kind of reminds me, it's like the plus 2 pi k thing. The plus c, it's similar to that. When it's like a full, it can be anything.
Right. Right. It's a little bit like that too, because when you put the like plus 2 pi k stuff on the end of a trig function, it means there's like infinite answers. It like goes on. It's kind of the same with the plus c, because c could be any number. There's infinite answers. But if like we restrict the domain on a trig function, if we say it's only from 0 to 2 pi, then you wouldn't use that anymore. This is kind of the same. We're saying only from 1 to 2, so you don't have to put the plus c on there. Now, it is possible to do this without doing what I just did. You could, in this case, have done 1/2. You could have done x equals 0, x equals 1, but you would need the x's there if you did that for it to be correct. U to the 3rd du, you would still do 1/2 times 1/4 u to the 4th. From this time it'd be x equals 0 and x equals 1. And you could change it back to x's. So you'd have 1/8. And then instead of u, you would have x squared plus 1 to the 4th. The x's would not be necessary anymore since we switched back to x's. And you'd have 1/8. We'd have 1 squared plus 1 to the 4th minus 0 squared plus 1 to the 4th. And this is going to give us 2 to the 4th minus 1 to the 4th, which you can see is what we got right here. But it's a lot quicker not to go back to the x's in that case. So once you have changed your limits, you don't ever have to go back to the x on that. This only works for definite integrals. We can't do that with indefinite integrals where we get the plus c on the end. Correct.
And then that's just your number.
That's your new number, yes.
Okay.
Yeah.
And then
Then
you
you integrate like we normally do. The only difference is we usually go like replace that u back with an x, but we don't have to do that here. You're just gonna, when you're integrating, after you've done your integral, then you just plug in the 2. My 1/4, I just brought it out here and put those together right there. So we were plugging 2 in here for our u, so we got 2 to the 4th, and then we were plugging the 1 in for the u, and that's where we got that 1 to the 4th. It's always going to be a minus whenever you integrate. So whenever you do a definite integral, you plug the top number in to your function, and then it's minus whatever you get when you plug the bottom number in. Okay? Questions? Let's do another one. Here's another one. Oh, wait, hold on. Put a square right there. Because otherwise we can't do that problem yet because we haven't done part C. But I think I checked your homework and you don't have any. I'll double check to make sure you don't have any that we needed to do part C first for. Okay, so for this problem, what do we need to use for our U? Okay, the whole denominator, just the stuff on the inside of the square root. Because it's going to complicate things if you got the square root there. So you're going to have U equals 2x squared minus 1. And then du. I hope this may work out where we're going to need a calculator because I changed that one thing about it. I hope it doesn't work out where we've got numbers that won't work, but we'll see. So what would du be for this? For x dx. So I've got the x that I need for my x dx, but I need a 4 right here. So if I put a 4 there in that numerator, what have I got to do on the outside? 1/4, right? And so I'm going to rewrite this a little more clearly. We're going to have 1/4 integral from 1 to 5. This is like having 1 over the square root of 2x squared minus 1 times 4x dx. You don't necessarily have to rewrite it like that, but I just want it to be very clear for you guys as we're going through it. So, as we said, this is our u. This part right here is our d. So when we switch to u's, the 1/4 stays out front. We've got 1 over the square root of u du. And we want to change our limits using this function that we've got for u right here. So 1, we're going to plug it in. So u is going to equal 2 times 1 squared minus 1, which is a little bit odd here. What do we get whenever we plug in 1? We also get 1, right? So it looks like it did not change, but we did plug it in. Then we're going to take 5. We're also going to plug it in here. So u equals 2 times 5 squared minus 1. This might actually work out because that's going to be 50 minus 1, so we'll get 49. So 49 is our upper limit. And so since we changed everything to u's now, we're not going back to x's. We're done with x's at this point. So I'm going to rewrite this one more time. It's 1/4 integral from 1 to 49. I'm going to rewrite it with a negative exponent so that I can take this integral a little more easily. It's u to the negative 1/2 du. And so my 1/4 kind of hangs out front. And then I'm going to increase my exponent by 1, so that's u to the 1/2. And I've got to divide out front by 1/2. So I'm dividing, I'm just going to go ahead and do it like this. It's fine since we only have one term. I'm dividing by 1/2 there. And then normally I'd put a plus c, but I don't want to for this because it's a definite integral, so I'll have from 1 to 49. And 1/4 divided by 1/2 is easy as pie. Flip the second and multiply, and you will get 2/4, which is 1/2. So we get 1/2. I'm going to turn that back into a square root of u, and we are evaluating that from 1 to 49. It's actually going to work out without a calculator. Are we okay here? All right, then we're plugging it in. So we got 1/2 square root of 49 minus 1/2 square root of 1. So this is going to be 7/2 minus 1/2, and that is going to give us 6/2, which is 3. I'm shocked that came out so nicely since I changed the problem there at the beginning. Okay, the majority of what you're doing is the same as what we've already been doing. The difference is that you're doing a definite interval, so you're going to change your limits, and you got that last part where you got to plug those numbers in. Okay, questions? All right, I want you guys just to work on this, so that's all we're doing. It's there's nothing else extra I'm adding today. Let me look back over these and make double sure. I think it actually is on page 342 for that. Let me make double sure that you can do all of these. Yeah, I'm pretty sure there's not any here that you need to know how to do part C for. So I think we should be good to work on these. So go ahead and get started. Hopefully you can get, it's on 342 instead of 341.